Hi, I'm Kai. I'm going to do the question 1 of homework 5 for probability and stochastic processes. The question 1, x and y are independent, and the density function of x is u of x minus 1 minus u of x minus 2, and the density function of y is u of y minus u of y minus 1, and we know z is equal to x plus y. And the first question, we need to use convolution method to find the density function of z. We know the density function of z is the convolution of fx of z and fy of z, and this part can be rewritten as the integral from negative infinity to infinity fx of alpha times fy of z minus alpha d alpha. So the first part, it will be u of alpha minus 1 minus u of alpha minus 2. The second part will be u of z minus alpha minus u of z minus alpha minus 1. For this integral, we can have 4 terms. So for the first term, this one times this one is u alpha minus 1 times u of z minus alpha. So for this integral, we can find the lower bound here, which is 1, and the upper bound here, which is z. And the step function u will be upper bound minus lower bound, which is u of z minus 1. So the result will be z minus 1 times u of z minus 1. For the second part, this term times this term, so it will be u of alpha minus 1 times u of z minus alpha minus 1. So the same, the lower bound here, which is 1, and the upper bound here, which is z minus 1. And for the step function, upper bound minus lower bound, so it will be z minus 2. So the final result will be minus z minus 2 times u of z minus 2. So for the third part, this term, this one times this one, so it will be u of alpha minus 2 times u of z minus alpha. So the lower bound here, which is 2, and the upper bound, which is z, and upper bound minus lower bound is z minus 2, so it will be minus z minus 2 times u of z minus 2. The last part, this term times this term, so it will be u of alpha minus 2 times u of z minus alpha minus 1. The lower bound, which is 2, and the upper bound, which is z minus 1. The step function, upper bound minus lower bound, would be z minus 3. So the result will be z minus 3 times u of z minus 3. So we can add this 4 terms together and get our density function of z, and it will be z minus 1 times u of z minus 1 minus z minus 2 of times u of z minus 2 minus z minus 2 times u of z minus 2 plus z minus 3 times u of z minus 3. The second question, we need to use a geometric method to find the density function of z. First, we can find the distribution function of z. The distribution function of z is the probability of z is less than or equal to z. And z is equal to x plus y. So it will be the probability of x plus y is less than or equal to z. So this one, by definition, it will be the double integral of f the joint density function of xy dx dy, and the region will be x plus y is less than or equal to z. And then we can calculate the z with fx is equal to ux minus u of x minus 1, and fy is equal to u of y minus u of y minus 1. The first condition, when z is less than 1. And now we can have our joint density function fxy. It will be 1. So the shade area f plus y is less than or equal to z. The area of this region will be the distribution function of z, which then we calculate this area of this triangle, and it will be z squared divided by 2. And then for the density function, we can take the derivative with respect to z, so it will be z. And the second condition, when z is between 1 and 2, and the same, the joint density function is 1. So the distribution function of z would be this shade region. Would be the area of this shade region. So for this shade region, we can calculate the area of the big triangle first, which is 1/2 times z squared, and then we minus these two small triangle, the area of these two small triangle, which is 2 times z minus 1 squared divided by 2. So the distribution function of z will be negative z squared divided by 2 times plus 2 times z minus 1. For the density function, we can take derivative with respect to z. So the result will be minus z plus 2. So now we have our density function of z. but our density function of x is u of x minus 1 minus u of x minus 2. So we need to shift this density function to the right side by 1. So the real density function of z will be z minus 1 when z is between 1 and 2, and negative z plus 3 when z is between 2 and 3, and 0 when z is otherwise.